Alright, welcome to a new module. Over the course of this module, we'll be training our Bayes classifier. But the first step is setting up our notebook and loading our data. In your projects folder, click on New, Python 3 Notebook. And let's give this a notebook a name. Let's call it 07 Bayes classifier hyphen training. To set up this notebook, let's add a few markdown cells. The first one will be notebook imports, and the second one will read constants. Under the notebook imports, let's import pandas as PD, and let's import numpy as NP. We always need these two guys. Under the constants, you can probably copy over some of them from the previous notebook. So in particular, I'm thinking of our two file paths and our vocabulary size. So I'm going to copy this over and paste it in here, and also add our vocab underscore size, which was 2,500. There we go. The very first thing we're going to do is load our features from the two text files into a numpy array. I'm going to add a markdown cell here to commemorate this. Read and load features from txt files into numpy array. The way we're going to do this is we're going to use the load txt function from numpy. Our training data comes as a sparse matrix. So I'll store this in a variable called sparse underscore train underscore data, and that's equal to np.load txt parentheses training data file, comma, delimiter, single quotes and a space, comma, data type or D type equals int. So what I'm doing here is, well, I'm giving everybody a chance who hasn't done the data pre-processing to come in at the training part of the project. And I'm doing this by calling a function from NumPy called loadText. And I'm supplying three arguments to this function. The first one is my relative path to my data file. We created this data file in the previous module, but you can also download it separately. The second thing is I'm adding a delimiter. Now, if you haven't heard this word before, a delimiter is a character that's used to specify the boundary between independent regions of plain text or data. We are using a single white space as our delimiter. And you can see this if you open your text file in a text editor. You can see that the single white space, it's what's used to separate the different values. The first value here is our document ID. The second value here is our word ID. The third value here is the category or label. So 1 for spam, 2 for non-spam. And the third value here is the occurrence, the number of times a particular word with, say, ID 0 occurs in the email with document ID 0. The white space separates these different kinds of data. Now we can open our wordbyid.csv file to give you an example of a different kind of delimiter. CSV, of course, stands for comma-separated values. So there you can see that the delimiter is, well, surprise, surprise, a comma. In this file, we have the word ID as the very first value in every single line, and we have the string, what this ID stands for, as the second kind of value. If you were to open this kind of file in Microsoft Excel or some other spreadsheet program, you'd see that all of these values get put into separate columns. So that's how a delimiter works. Lastly, I've supplied some information about the kind of data that we're importing here. we're exclusively dealing with whole numbers, right? Our document IDs are whole numbers, our word IDs are whole numbers, our categories are whole numbers, and the number of times a particular word occurs is also a whole number. So I've set the data type as an integer. Let me hit Shift Enter on this cell. You'll see that it runs a little while, and let's import our test data as well. So sparse underscore test underscore data is equal to np dot load txt, and then it'll be test data file, which is our relative path to our test -data.txt, and it also has the same delimiter, a single space, and it also has the same data type, an integer. So now we have two NumPy arrays. Let's see if we loaded them successfully by maybe just looking at the first 5 and the last 5 rows. So I'll pick sparse train data and have maybe a square bracket, colon, and a 5 to look at the first 5 rows. And to just verify that the last 5 rows are okay, I can use the square bracket notation, but this time I'll put -5 and then a colon at the end. There we go. And if you do this, what you should see is that there's a match between the values in the text file and the values that are shown here as an output in Jupyter Notebook. Now, both of these arrays are actually quite large. And to give you an idea of the kind of data that we're working with here, let's print out the number of rows in both the training and the test file, and let's print out the number of emails that we're working with in our training file and our testing files. Managed to grab this kind of data a couple of times before with data frames, but now that we've got a NumPy array here, let me show you the methods that you'd use to accomplish the same thing. So I'll wrap everything in the print statement. Print, parentheses, single quotes, number of rows in training file, comma, and that'll be our sparse train data, dot, shape, square brackets, 0. Copy this line, paste it below, and then I'll just swap training for test, and hit Shift Enter. There you can see that we've got quite a few entries in both of these files. Our training file has about 265,000 rows, and our testing file has 110,000 rows. The number of unique emails, though, will be determined by the number of unique document IDs that are contained in these matrices. So I can print these out with print, single quotes, number of emails in training file, put a comma after it, and then I'll use NumPy's unique method. So np.unique, parentheses, sparse train data, and then I'll put a square brackets afterwards and maybe select everything right in the first column. That way I'm only selecting the document IDs. Semicolon, comma, 0. This is the notation for selecting all the rows in the first column. And then because this will actually return another array, I have to chain on an attribute here, namely the size attribute. Let's see if this works. There we go. The number of emails in the training file is 4,014. If we check out the number of unique emails in the testing file, then we just swap this over for test and hit Shift Enter, and we see that we're working with 1,723 different emails in the testing file. So there we go. I think that completes our setup and importing the data. We've also talked about the format that our data is in. We've got 4 columns. The first one is a document ID, which identifies a particular email. The second one is a word ID, which identifies a particular token or word. The third one here is our label or category. So 0 for non-spam and 1 for spam. And the fourth one here is the number of times this particular word occurs in the email. In the next lessons, we'll be transforming this NumPy array into a pandas data frame, and we're also going to be restructuring it so that it's no longer a sparse matrix, but instead it's a full matrix. If you remember, the full matrix included the 0 values, the sparse matrix did not. Looking forward to seeing you in the next lessons.